Okay, my friends, let's get into some other measures of center. The most common you're probably going to hear, besides percentage, which is pretty common, is something called an average. And I'm just going to jump in and talk about the sample average in this case. Now, the sample average has a fancy little title, X bar. We'll talk about that in a second. We need some data to play with averages, though, and medians and modes, which we're about to get into. So here, I grabbed some data from my bike commutes. Here's a number of miles I traveled when I have to go home from work and stop and run errands at the local little supermarket between here and my home. So these are the miles that are logged on that particular route. So leave work, go home, but in between stop and run some errands at the local supermarket. Okay, so you got a bunch of numbers there. So if I asked you to find the average of those numbers, I bet you'd say something like this. Add them all up and divide by how many there are. I guarantee that's what you would do. Okay, we'll get back to that in a second. What I want to talk about now is some notation. Now, I don't believe statistics should all be about notation. I don't believe that at all. But I do know that those of you moving past statistics 1 into like Math 244 or beyond, you're going to see these symbols as you go. So here's a look at what a sample average formula actually looks like. And it looks terrifying, but it's not. So X bar, that's the first part of this, X bar. That simply means you're talking about the average of a sample. Why is this a sample over here? Because this is just 16 of these trips. I only grabbed a small subset of them. That's why it's a sample and not the entire population. We'll come back to that in a second. Okay, so that's X bar. That's the name for the average of a sample. What's that numerator? Well, that big thing right there is called sigma, and that's the Greek letter for S, which is the first letter in the word sum. So statisticians have used capital sigma to place next to the X to say, add up all of your data. So when you see a big sigma, it means add up everything you've got, and the thing next to it means what do you got? So this can be a little bit confusing at first. X bar is the average itself, but just a simple X is an individual data point. And a big sigma next to that individual X just simply means to add up everything you've got. And then you're going to divide by how many data points there are, just like you did before. It's still your sample size. So that formula, although it might look a little daunting at first, is exactly the way you've taken an average your entire life. Now for this particular data, if I add up all those data points, I get 196.91 total miles. And if I divide that by the 16 trips that are indicated, I get an average of 12.31 miles per trip. Now, I am not going to make you add up those 16 numbers and then divide by 16. Heck no. That's why we invented Excel. So here's a little illustration of how you use the function average in Excel to calculate the average of a group of numbers. So it's been playing there as I've been chatting. It's as simple as typing equals average, then selecting all the numbers you want to average, and then pressing enter, and boom, there's your average. Okay, so a sample average is when you add up all the data in your sample and then divide by how large your sample is. Pretty straightforward. Now, why did I start with the sample average? Well, because there is a population average. And of course, because we're statisticians, we have to give it its own name. And its name is the Greek letter mu, which is that funny looking little U thing with a tail. Why mu? Well, mu starts with M, and M is the first letter of the word mean. Another word for average is mean, M-E-A-N. Okay, and we're not going to talk much about that because that word gets used not quite as much as the word average. But if you ever hear the mean of a group of numbers, they're talking about the average. Look at the formula. It's add up all the data and divide by how many data points there are. The only thing I change, and I've seen this in some texts, is that they use a capital N for the population size. But the calculation is exactly the same. So why did I start by looking at the sample average? It seems like you want the population average, right? I mean, that's what you'd be interested in, is your actual entire population. Well, true, except the sample is what you usually get. You can't get the whole population usually. You usually can get a sample. So that's why I led with the sample average, because the sample average, again, it's a statistic versus the population average being a parameter. But what I want you to think, finding averages is pretty straightforward. You've done it for years. What I want you to think before we move on to the median is, why do we use averages? Think about that. We'll ask you again on the homework. But why add up all the data and then divide it? How come? Think about that. And after you've thought about it enough, let's move to the median. All right, the sample median. Okay, so you may have heard this one before. If you haven't, that's totally fine. The median is more conversational than formulaic. The way you find it is you put all your data in order, either ascending or descending. It doesn't matter, and you'll see why in a second. And find the data point that's in the positional middle. Now, what do I mean by that? Well, I'm going to start by putting the data in order. So there is the exact same data, but it's laid out in a ascending format. The least number of miles I traveled on those errand commutes was 11.65. The most was 13.41, and they're in order going up. So what we do now is we have to find the data points that are in, I said, the positional middle. So what that means is we're going to cross off the smallest and cross off the biggest, then cross off the next smallest, then cross off the next biggest, and we're going to keep going this back and forth, back and forth, back and forth, until we end up, in this case, there are two numbers that are in the middle, 12.2 and 12.22. So we pick as the middle, positional middle, the number directly between them, which would be 12.21. So we would say the median number of miles I commute when I have to do errands on the way home would be 12.21 miles. That's all there is to it. The only downside is if your data sets get much bigger, this process gets a little bit tedious, but that's where spreadsheets come in handy. So you can use the function equals median, which you're seeing work right now, and it pops out the exact same measure for you with little to no effort. All right, let's look at one more of the M measures of center. The sample mode, this is our third M measure after mean and median. So the mode, if you thought the median didn't have a lot of math involved, the mode has even less. All you got to do is go into your data set and find the most frequently occurring data point if it exists. So our data set actually does have a mode, which surprised me actually. You can't really see it easily unless you sort the data again, so I will. And right there, you see how there are two instances of 12.22 miles? That tells us that our sample mode is 12.22 miles. You can also use the mode as an adjective. The modal distance is 12.22 miles. And just like before, you can use Excel to find the mode. And it'll save you a whole bunch of time. But there is a catch. When you use Excel to find the mode, if your data set has more than one mode, for example, if I go in here and just change this data point to 13.34, now the data set actually has two modes, 13.34 and 12.22. And if I change this one to 11.65, it now has three modes, but Excel still only gives one. So that is a limitation you have to be aware of with Excel. So a data set can have no modes at all, just one mode, 2, 3, or more. We'll talk more of this as we go forward, but that's enough for the first day.